All right, sixth graders, let's review multiplying and dividing with decimals. All right, for this first one, I'm just pretending that there is no decimal point. So the steps for multiplying decimals is multiply them by ignoring the decimal point. Then we're going to make an adjustment at the end. So let's go ahead and multiply this as 262 times 5. I'm going to multiply just like I would any long multiplication problem. 5 times 2 is 10. 5 times 6 is 30. Plus 1 is 31. 5 times 2 is 10 again. Plus 3 is 13. Now, there's two ways to put my decimal into my answer. One of the ways is to estimate. So if I look at this number, this is close to 3, and this number is exactly 5. So if I took 3 times 5, I know my answer should be somewhere near 15. Okay, so if I was doing that and I'm looking at this problem, if I put it here, that's way too small. If I put it here, that's still pretty small. If I put it here, ding, 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 13.1, that's as close to 15 as I can get. I could put it here and it's way too big, way too big, okay? So we know that it belongs right here. We know it belongs there because of my estimation. Now, not always will estimation be the easiest thing. We'll find that out in the next problem. But it works in some problems, and it's a great way to check your answer when you're all done if it is one that estimates nicely. Okay, so let's pretend it doesn't estimate nicely. Another way we can do this is we can count the number of decimal places in the problem and then adjust our answer. So if I look in this problem, I have 1, 2 decimal places there, and there aren't any decimal places here because there's nothing behind the decimal point. Okay, so I have a total of 2. So I'm going to move from the back forward 2 spaces, and there it is, 13.1 or 13.10. This 0 doesn't need to be there anymore because we moved the decimal point. Okay, let's do the second one. I'm going to take the second one, I'm going to times it like 45 times 18. I'm ignoring those decimal places. Now I'm going to multiply. I got 40 and 36. Okay, I'm going to add a 0 when I move on to the tens place. So I've got 5 and 4. Add those up. 11. Okay, we know my answer is in 810. We know that for sure. So when we're looking at this problem and we're saying something really teeny tiny times about 2, okay, you know that's not going to end up being 810. I hope that is very obvious. But we're not exactly sure. I mean, this would round to 0. So if this rounds to 0 and this rounds to 2, well, 0 kind of changes things a lot, but we'd say this is close to 0. Geez, I mean, I could put my decimal in a lot of places that would make it close to 0, but definitely in front of the 8, right? So let's go ahead and use our second method. Let's count the decimal places. So we're going to count 1, 2, 3. For a total of 3 decimal places, I'm going to start at the end and I'm going to move 1, 2, 3 decimal places. There it is right there. I like to put a 0 in front of my decimal, and then this one doesn't need to be there. Moving on to division. Okay, when I divide, I'm going to take this first number and I'm going to put it inside the box, 573.3. And I'm going to take this second number and I'm going to put it outside the box, okay? This is the dividend, this is the divisor. So next thing is if I have a whole number on the outside of my box, I can go ahead and start. If I have a decimal, which we'll have on the next slide, I'll show you what you need to do. So the first thing I like to do when I have a big number like 13, and it might not be the one that I know super well in my head, I'm going to list my multiplication facts of 13. So 1 times 13 is 13. 2 times 13 is 26. 3 times 13 is 39. 4 times 13 is 52. And you could just use your planner for this. Oops, that's a 4. Let me write that in a different color. 4, and this is a 5, okay? And then we'll do one more. 78 is 6. We might need to go further than that, but let's leave it at that for right now. So if I'm asking myself, how many 13s fit into 5? Well, that's obvious. None, okay? So let's move on and use both of these places. 13 goes into 57. Well, down here, 52 fits. So I'm going to go 4 times, and 4 times 13 is 52. Remember, divide, multiply, subtract, and bring down. That's the steps we do over and over and over when we do long division. So I divided, I multiplied. Now I'm going to subtract, and I'm going to bring down the next number. Oops, that's a 5. 52. Okay, so now how many 13s fit into 53? All right, well, 52 works again, so 4 again. 4 times 13 is 52. So I divided, I multiplied, I'm subtracting. And when I bring down this 3, did you notice that I passed by the decimal point? When we pass the decimal point, we're going to float it right up into our answer. This is where it's really nice. If you need to, you can use graph paper on the test for this, but it's really nice to stay kind of neat and organized. And lastly, 13 goes into 13 just one time. 1 times 13 is 13. I am done when I get to no more numbers up here, and I got a 0 down below. If I need to, I can keep adding zeros up here in order to keep the problem going. So that's my answer, 44.1. Okay, we can estimate on this one too, but this one's pretty big numbers to be estimating in our heads. Now, if I were to look at this one, I would say this is pretty, I mean, it's smaller, but it's pretty close to 900, right? So my answer is going to be somewhere around 100. I made this one bigger, so then I know that my answer is going to actually be slightly smaller than 100. Let's check it out. So again, we're going to start with 807.3 inside the box. On the outside of the box, 9. 9, I know my 9s. Hopefully you know your 9s. Otherwise, you can use your multiplication table again. I know 9 goes into 8 0 times. 0 times 9 is 0, so I'm going to move on and do 80. 9 times 8 is 72. I divide, multiply, subtract, and bring down. 9 times 9 is 81. Subtract, and oh, look at when I'm bringing that down. What did I pass? Bring up my decimal point. Okay, and 9 goes into 63 exactly 7 times. I am done. 89.7. Okay, is that close to my estimate of 100? Yes, it is. So I know I did it right. All right, now we have a situation where we have a decimal divided by another decimal. So let's go ahead and write it like we would. And we are going to discover the problem when we start to say how many 0.3s fit into 2. Now, you might be able to do that in your head, but I'm going to suggest that some of these get a really bit tricky, and so it's nicer to make an adjustment. We can adjust by multiplying by the same thing. So I could multiply this side by 2 and this side by 2, like this side by 2 and this side by 2, and I'd get the same answer. I could multiply this side by 10 and this side by 10, and I'd get the same answer. We did that in class where we did a couple example problems to prove that that worked. So we always will multiply by a power of 10 because it keeps things simpler. Now, when I do this, what I'd like you to think about is even though we're multiplying by a power of 10, you're trying to eliminate a decimal point. So I'm looking at this and I say, I want to get that decimal point gone. What do I need to do to get it gone or get it to the end of the problem? I need to move it once, okay? Whatever I do to this one to make it a whole number, I'm going to do to this one. This one very likely is going to stay a decimal, okay? So don't just move it to the end. You're going to move your decimal to the wrong spot, I'm sure. So it's not moving to the end. It's moving the same amount of places as this one. So that one moved once. This one's moving once. I'm going to rewrite this. 28.2 divided by, now I have just a 3 out here. Much easier. It's going to give me the same answer, no adjustments needed. So 3 goes into 2. It doesn't. 3 goes into 28, 9 times. 9 times 3 is 27. Subtract, bring down a 2. But when I bring down that 2, I notice I passed by my decimal point, floated up into my answer. 3 times 4 is 12 exactly. So I am done. Okay. This one, not at all obvious if we were trying to estimate. So we have to go based on what we know in order to know that that's good. That's the right answer. Now you could think, okay, this is about a third and this is about 3. So you could say, oh, that's about 10 then. But that takes a little bit of higher level math to do. Now the second one over here, I'm going to move this decimal point 2 times. Okay, so I'm adjusting it 2 times. It's going to go here. I very strongly suggest you rewrite these problems because the decimal points get really fuzzy otherwise. I can completely eliminate that 0. Okay, I'm now talking about 53.9. Okay, on the inside, and then on the outside, 14. Here's another situation where I'd want to say, okay, 1 times 14 is 14, 2 times 14 is 28, 3 times 14 is 52. Wait a minute, I went too high. 42. 4 times 14 is 56. 5 times 14 is 70. We'll go to 6 again. 6 times 14 is 84. All right, we'll see if we need to go further than that. So again, 14 goes into 5, 0 times. 14 goes into 53, 3 times. 3 times 14 is 42. Subtract, I get 11. When I bring down this 9, I got to bring up my decimal point. Uh-oh, we've got a little bit of a problem. I only go to 84 here, so I got to add some more. So 7 times 14. So I'm going to go 98. I could probably do 8. Let's see. 14 is 112. Yep, that's where I'm at. So 8 times 14 is 112. Subtract, I get 7. Here's a situation where I still have a number here, but I ran out of numbers up top. So I'm going to add a 0, and I'm going to bring it down. Okay, remember, if there's a decimal point here, I can add as many zeros as I need. I don't want to use them unless I need them. Okay, so 14 goes into 70. Look at that, exactly 5 times. 5 times 14 is 70, and I am finished. I hope this is helpful. There's a fraction video as well. Please watch both. Have a great night. Good luck studying.